Hello everyone, this is Suresh from Azure ADB. Today our topic is how to handle scientific notated values. So for example, the scientific values will look like this. So if number is very big, then it will convert instead of double value, instead of string value, it will read as double type. Data type will read as double type, and it is like 1 point and these many digits, and at the end you will see e exponential 17. So this number may be different and depends on the number of digits, but the actual value should be like this. So this kind of scenarios when you will face is if you are working in data engineering projects, and mainly whenever you load data from source to bronze tables. So from source to bronze tables, you will get data like this sometimes. And if you see at source side, it it will be as data type as string type, and the value will be like this. Actual value will be like this in your source. But whenever you read into bronze table, your data type will change from string to double type, and this value also look like this. Then how to handle these values? So here we have different methods how to handle this one. So first what I'm doing, I'm importing this required functions here. And my first scenario is keep precise values by using cast method changing to decimal type. So here I'm using two methods. One is a display and one more is show method. So in display, here what I'm doing, first I'm trying to print single row. So for that, I return code spark dot range one, and on top of that, select. Here I'm using expression because I'm writing here Spark SQL code here. So whenever you want to write Spark SQL code, you have to write expression, and this expression you have to import it from here. PySpark.sql.functions import expression. And within expression, you have to start and ending with double quote, and you have to write your SQL code. So here what I'm doing, so this is my actual this scientific value. So this value I want to cast to decimal value. So for that what I'm doing in SQL, first we'll write cast and this number as decimal 3820. And I given alias column name as x underscore December. And see, after casting this one, casting this value, here I'm getting double data type decimal. Okay. And what it means 38 20 is 38 is total digits and 20 is digits after decimal points. So that means if you create this data frame, you will get this one. You will get this data frame. Since I used to display df1, and since I used to df1.print schema, it telling that data type is this one, decimal 3820. And even after converting as decimal 3820, see it displaying still as decimal scientific value only. So here I used display method. Next, what I'm doing, I'm trying to do with show method. Same code, only difference is I used df2.show. So data type also same. If I use df2.show with empty argument, what it will happen is instead of scientific value, it generating the value, expanded value, but this show method, it has some limitation of digits. So if it is exceeds, it will show like this three dots. So three dots means it has still digits. And what is the solution is inside show, if you write truncate equal to false, it will show you full value. And whatever this 20 is there, so here what it mentioned, 20 means 20 digits after decimal point. So here our decimal point is this one. After point, you will see this 20 digits you will see here. And so this is a difference between show and display. And why in display method, why it shows scientific value is, so here we can see, like, even though if you're casting to decimal value, what happening is Spark stores it correctly as decimal. So inside memory, it will store as actual decimal value. That means like this. But display function is related to Databricks. This is Databricks developed. So here, what this display method doing is it formats all small numbers in scientific notation. So that means whenever it number of digits it increase, it will show like this. But internally it will store as like this actual value. Okay, so that is one difference. So next what I'm doing, I'm creating one data frame here. One is ID and second is X underscore decimal. My table name is decimal underscore data. So here I'm passing these values here. So one value is e power minus 8, e power minus 5, and here we don't have e, and here also don't have e. So if I call this table, this is the output I'm getting. See, one is 8 I'm getting, e power 8 I'm getting, so 2.5. So 2.5 e4 minus 5. So we are getting like this. So instead of 2.5 e5, we are getting like this. And this we are getting as it is. These two we are getting as it is. Now what I'm doing is, since I created SQL table, if I want to perform PySpark operations, what I need to do, I need to call using this option, spark.table, and inside that I need to pass this table name. So decimal underscore data. So now my Spark data frame is stored here. And on top of this data frame, that means on top of these two columns, what I'm doing is I'm adding one more column, that is X underscore decimal casted. And here what I'm doing, on top of this column, I'm applying cast method to this one, decimal type 3820. So now what happening, if you see after casting to decimal type, say this one we are getting as it is, and if you see here this one after decimal point, you will see 20 digits you will see, and here also 20 digits, here also 20 digits, and here why it not showing is it is more than 20 digits. Maybe suppose I will try to increase this one, so 20 to 30. We'll see how output comes. So very first time it will take some time. Let's wait for a few seconds. Very first time it will take time. Okay. See here, even though after given 30, still it is not converting, but it digits are increasing, but it not come. Maybe I will try for 35 just to show the difference. Later will change to 20. Still -8. Okay, so decimal scale cannot be greater than the precision. So this is 38. Here 48 is there. So I will give 38. Okay, maybe I'll give 40. Decimal precision 40 exceeds maximum precision. Okay, I think maximum is 38. I'll try here for 37. Double cannot be represented as necessary. I need to decide. So what I will do, I will try for 20. Okay, so accept the first value. So remaining all getting up to 20 digit. So next what I'm doing, show or export without scientific notation. So that means increase the precision as needed. So for precision, we need to do right like this, percent point to off. So this is especially useful before writing CSV or TSV. So values won't appear in scientific notation. So for this, I'm creating one more sample data frame. So that is decimal format data. So decimal format data. So this thing, what I'm doing here is, since it is a SQL table, I'm reading through Spark dot table. And after reading, I'm using format underscore string, format underscore string function here. So here I'm using percent 1.5 F and I'm mentioning the column name. So now what will happen? This value, see these values, it changing to like this. Okay, so what it means 0.115 is, see here format underscore string percent 1.5 F. So it converts number to fixed decimal string and it avoids scientific notation. And here percent 15 percent 0.15 F. So that means 15 digits after decimal. So you can change, like example, you can use like 0.10, 0.2 also. That means three different digits we can use. So 10, 15, 20. Okay, so it will remove this scientific number and it will expand up to your defined format string. Okay, so next, how to scale to integers or keep decimals. So that means first we'll say go for stay in decimal. So here also I created one sample data frame. So through SQL I created and table name is this one, decimal scale data. And if you see here, here we have scientific numbers and this SQL table, I am reading through this one, spark dot table. And after that, on top of this data frame, I'm adding two columns. So one is this one, x underscore basic, y underscore basic. That means decimal number. So on this column, on this call of x, so that means on this x column, I'm doing cast. So that means I'm changing to decimal type up to this position. So if I change this cast one, what I'm getting here is, see here, it changing up to here 20 means after digit 20. So if you see this one and this one, so it printing up to 10, 10, 12, 125, and so on is there. So what it doing, whatever here 25 is there, it rounding off 3. And here 5 e4 minus 8. So that it converting to like this. And similar way, so this one, see here, it converting up to here. See here, in this case, you can see here up to 20 digits. And here 10.5 also you can see up to 20 digits. And similar way, you can do one more thing, like if you want to totally remove this exponential, what you can do is, whatever we got this output, we can multiply with this value. You can multiply with this value first, then you can cast using decimal type. Decimal type precision is 38 and we are keeping 0. That means after digit 0 numbers I need. So that means I don't want any decimal type, I want only integer values. So after multiplying this value with this one, and if you apply this cast, see we are getting only 1. So remaining all it ignoring, just rounding off 1. So here 5, and here it printing only this value, and here 105. Okay, so this is one method. And second one is, so here I given this big value, no? So instead of that, what you can write is scale to integers. So to avoid this one, so you can use scale. So scale means I'm defining one variable. Instead of that value, what I'm giving 10 double star 8 exponential 10 exponential 8. And this scale value I'm passing here. If you see earlier, here I multiplied. So here I multiplied, but here I'm multiplying with scale. So after doing scale, I'm doing changing the data type to long type. So first what it doing, on top of this x column, first I'm converting to decimal type. After converting this decimal type, I'm multiplying this value. And after multiplying, I'm changing decimal type to long type. So I will get same result. So whichever method you are comfortable, you can use it. So either this method or this method. And one more is, so this is like a real-time use case. So real-time use cases. So for demo purpose, I created a simple data frame like spark.create data frame. But if you see in real time, from your source to your storage account, either you will get CSV or Parquet files. So those files, uh, from your source side, if you look, these will be like string number. It will be like string number without exponential. But once you move data from source to storage account, suppose in case of CSV files, if you open that CSV files, the data will look like this. And same thing, if you move the data from your storage account to bronze layer, you also get in bronze tables, you will get same value with exponential. And one more problem is, if you see at source side, this will be like string type, but whenever reading in PySpark, that means, oh, while moving data to bronze table, it will read as double type. So there are two disadvantages. One is data type mismatch and value mismatch. So here, what I'm doing after creating this data frame, what I'm doing on top of that, I'm using, this is not exact method, this is temporary method I'm telling. So if I use this method, what issue will come at real time? So here I'm using with column on top of this column, and this whatever this column is there, product ID. First, I'm converting to long type. If I convert to long type, what will happen? This double type, it will convert to integer value. And after converting integer value, I will change data type to string. Maybe what I will do, I will run this data frame, and instead of this one, okay, with column, same only, I will try to edit. So here I will add same line of code, but but without cast to string type. So now here one, and white showing. So this is one bracket. So here one bracket, and this is closing bracket. But still, okay, there is no open. Instead of this, what I will do at the starting and ending, I will close. Okay, so now what will happen? This I will change with column product ID long. Now we'll get add one more column. So this particular column, first I am changing to long type. So one difference is it converted from double to big integer. Big integer means long type. And if you see the value, here 1.2 is there, here exponential is a scientific number. So this it converted to long type. So that means without exponential value. And if you see the values, 29001, 29001, and this is generating like this 96. Okay, so later I want to change to string type. Why? Because in my source I have string type. So bronze table also I want to maintain as string type. So I'm using cast as string type. So here what I'm doing, this particular column, first I'm changing to long type by using cast long, and after that by using one more cast, I'm changing to string type. Okay, so this is one method, and one more method is by using this one, cast decimal type. So same column, this particular column, I'm using this cast underscore decimal type. So here what I did, I used first long type, then a string type. So instead of that, what I'm doing, decimal type 38 0. So if I do cast decimal type, what it happening? It changing from double to decimal type and up to this ratio. See here also we are eliminating exponential, and result we are getting same. What we are getting here. So this is method 2. So either of the method you can use it. Okay. So next we'll go for next use case. So here, yeah, before that we have to go through some basics here. Like Spark treats this as a double. So that means whenever your source has more number of digits, it will treats as double type. So even though it is a string type, it will read as double type. That is one thing. And one more thing is this double losses precision for large numbers. Why? Because in our source, side, value may be different. Some value will be there. After converting to scientific number, so there is chance of losing the data because data type is converting and it is changing to scientific number. So there may be chances of losing precision. So even if you convert this one, the value may already be slightly wrong. Okay, so this is one issue. So then what is the best practices for without losing precision? So define schema as string initially. So I will tell you one real-time case. Same thing from source while reading. No? Initially, we got this issue. So while moving data to bronze table, data type got changed. It changed from string to double, and it converted to scientific number. So, but in silver and gold layers, we should not have this scientific numbers because this column may get joined, not maybe column. This table will get joined to other table, and sometimes there is possibility of um, multiplying with other column. And one more thing is, if this particular column is your main column, that means whatever you are doing group by aggregations based on this column, then it will become problem. So whenever you do unit testing and some other testing, so your count will not match. When you compare with the source and your target, your count will not get match. Why? Because since it is converted to scientific number, even though if you use these methods and you try to convert to integer value, so there is chances of uh, losing the data. So for those cases, what is the best method is while reading the data itself, define the schema as string type. So for that example is, so I'm creating data frame here. So this is my value. That is, you assume that this is the actual value and this value I'm reading as string type. So I have two columns, ID and product ID. I'm defining as string type. So here my column is string type. So on top of that, I'm using this one, cast dot decimal type. So now I won't get any loss. Okay, so one more use case is I have one data frame like this. I have two columns here. I defined schema here, ID and var, and here my data type is integer type, and this also integer type. Here what I'm doing, first I'm creating the data frame by using spark.create data frame, and I'm adding one column that is new underscore val. Here what I'm doing, call value. So that means all second column. Yeah, all these values I am dividing with some value. So this is just to show the scientific number. So after dividing, I am selecting ID val new underscore value. So after dividing all these values with this particular value, so we are getting scientific numbers like this. Okay, now what I'm doing here, see, after converting, it become double type. So here represented as scientific number, and we call it e to the power of numbers. So e to the power of 8 minus 8. So the values are presented in exponential format, that is numbers with e near the end. So if you are reading data from any database via JDBC connection and the data type is decimal with scale more than 6, then the value is converted to exponential format. Okay. So now what I'm doing here is, here I'm using one more method like format underscore number. So here in select, I'm calling these columns ID and val, and I'm using format underscore number function on this new val column. And I want up to 10 digits. So if I print this one, so where is my actual value? Actual column is this one. So this column, see, it looks like this. And this one I'm converting like this. So that means I'm printing up to 10 decimals. After digit, I'm printing 10 digits. Whether it may have any number of things. If you see here at any number of digits, but I want after that only 10 digits. See here. So this is one more method. So these are all the different methods we can use to handle the scientific values. So that's all about this video. If you really like this video, please like and subscribe. Thank you.